Listo, bueno, entonces estábamos trabajando con cómo volver un bloque de código que ya habíamos hecho, que es el convertidor de emojis en una función. Eh, estaba ya la convertí en una función, sin embargo, no me está queriendo devolver lo que necesito que me devuelva por algún motivo. Andrés, necesito que me devuelva esto, pero no sé por qué no me lo quiere devolver. Tan. No sé, pronto está mal acá el botón. Debería estar acá. No. Eh, 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 eh. Customer, cuando account. Mm, mm, mm. Vamos a preguntar, a la ChatGPT si tengo una pregunta. El return en las funciones. The return in functions, just return numbers or a string or character. Está un poco lento el ChatGPT por estar. Eso es lo que no me ha gustado. Como utiliza el mismo servidor, utiliza todas las mismas funcionalidades del computador, se vuelve muy lento. No, en Python la clave retorna una función por el proyecto de Python no solo los cambios de texto. Incluso listas que retornando un número, ok. Coordenadas duplas. Obtener usuario. Retornando un diccionario. Es que no quiero preguntarle el por qué, pero sí quiero saber por qué. Here does not return my variable. No está haciendo nada con el valor que retorno. Imprimir. O haciendo luego imprimir. Input is print. Esto sí lo tengo que imprimir. ¡Qué marica! I'm happy to have you accept the print como. ¡Qué marica! ¿Cómo no lo voy a imprimir? Uy, qué rabia. Y es que son cosas que son tan estúpidas, pero que huelen tanto no hacerlas. Ush.
Will not be reusable. You want to give our function the actual message as a string. We don't care how we got that message. In one program, we might get it from the terminal. In another program, we might get it from a graphical user interface. So that is the reason this line of code should not be in that function. By the same token, you shouldn't include the last line in that function because what we do with the output is different from one program to another. In this program, we're printing the output. In another program, we might send that output as an email or as a response in a chat application. So as a general rule of thumb, your functions should not worry about receiving input and printing it. These lines of code should not belong to your functions. So go ahead and reorganize this code by
Porque no le puse cuidado al man.
your functions should not worry about receiving input. By default, all functions in Python return. Here's the code for our emoji converter program that we wrote earlier. If you missed that tutorial, make sure to go back and watch it. As I told you before, there is a table of content right below this video in the description. So you can simply click on the emoji converter tutorial to watch it. Now, your exercise is to reorganize this code using a function. So I want you to extract a function in this code. Because this algorithm for converting these smiley faces into emojis is something that we probably want to use in a lot of different applications. We can use it in a chat application, in an email application, and so on. We don't want to write all this code every time. We want to convert these characters into smiley faces. So out of all these lines of code that we have, from line 1 to line 10, the lines 2 to 9 belong to our algorithm. All these lines together implement this feature. So you should put these lines in a separate function. Now, why don't we have the input in that function? Because the input can come in different forms. Currently, we're using the input function to receive the input from the terminal, but in other applications, we might receive the input from a graphical user interface. So the input can come in different forms. We don't want to put that in our function because this line will not be reusable. We want to give our function the actual message as a string. We don't care how we got that message. In one program, we might get it from the terminal. In another program, we might get it from a graphical user interface. So that is the reason this line of code should not be in that function. By the same token, you shouldn't include the last line and not be in that function, a graphical user interface. So that is the reason that we don't care how we got that message. In one program, we might get it from the terminal. In another program, we might get it from a graphical user interface. So that is the reason this line of code should not be in that function. By the same token, you shouldn't include the last line in that function because what we do with the output is different from one program to another. In this program, we're printing the output. In another program, we might send that output as an email or as a response in a chat application. So as a general rule of thumb, your functions should not worry about receiving input and printing it. These lines of code should not belong to your functions. So go ahead and reorganize this code by extracting a function. All right, on the top, first we need to define our function. So we type def, give our function a name, like emoji underline converter. So the name of this function clearly tells me what it does. Each function should be responsible for one and only one task, and that task should be clearly explained in the name of the function, okay? So our emoji converter function should take a parameter, we call that message, that is a string, right? Colon. Now we need to move the lines 5 all the way to the end of our for block into that function. So let's select all these lines. We can cut them from here by pressing Command and X on Mac or Control and X on Windows. Then we paste them here. As you can see, these lines are automatically indented, so they are part of the emoji converter function. If this didn't happen on your computer, make sure to select these lines and use the tab to indent them. All right, so here's our emoji converter function. Beautiful. Now, after that, in the main flow of our program, first we get the input from the user. We store it in this variable message, and then we call emoji converter and pass this message. This function should return a value. That is what we calculate at the end of this function. So right after this for block, we need to add a return statement, return output. Now that our function returns a value, we can get it and store it in a separate variable. Let's call that result. And then we can simply print that here, or we can make this code shorter. We don't really need this variable here. So we can simply call the emoji converter and print the result like this. Now here we have an underline because, as I told you before, we need 2 blank lines after our function definitions. So currently we have only 1 blank line. We need to add another blank line. Good. Let's go ahead and run this program to make sure everything works as before. So I'm going to type a message like good morning with a smiley face. Good. Let's run it one more time. I'm sad. Too bad. Okay, beautiful. So here's the final.
Big hello to my friends in Canada. One of the most important skills you can develop to give you the most amount of career progression, to give you a competitive advantage in your life, is the skill of public speaking, the skill of communication. Now, if you want to learn this and upgrade your skills, come join me for a masterclass. It's completely free, and I'm going to teach you 3 powerful communication frameworks that's going to level up this skill set of yours. Come join me on Wednesday, the 19th of February at 4:30 p.m. or Friday, the 21st of February at 12:30 a.m. Eastern Time. If you show up live, we've got prizes.
Result. We defined this function called emoji converter. This function takes a parameter called message and finally returns the output.
Exceptions. Code. Exceptions.
In this tutorial, I'm going to teach you guys how to handle errors in your Python programs.
Okay, one question. I know in Java, we have the block code to catch errors. En Java tenemos public, polyform, class abstractas, exceptions, manejo de excepciones. Sí. We have cat to and we have manage and we manage the errors with exceptions. We have checked and unchecked. The check errors are when we know how to handle the error, and we presume that the error we know where the error is going to appear. And the other thing, the other exception is unchecked when are those errors that we don't know, we do not know that they are going to appear. So it's similar to Python. Sont divisés en 2 grandes catégories, check et uncheck non vérifié. La différence principale entre les deux réside dans la manière dont ils sont gérés, si j'avais essayé de les manipuler ou non. A trick must be handled with try catch or declare with throws, with exception and check exception occur at runtime and subclasses. Okay. In Python, all exceptions are unchecked, meaning there is no requirement to catch them, but we can handle them using try, similar to try catch in Java. Try except similar to try catch. Okay, manipulate exception handling like catching multiple sections in Java. Try, okay, enter number, print. So you cannot divide by 0, invalid input, and please enter a number. Handle no exceptions. Main difference with Java, Python doesn't have checked exceptions. You are not forced to handle exceptions. All exceptions are unchecked, meaning if you don't handle them, the program crashes. Less boilerplate, no need to declare exceptions in function signatures through exception. Less boilerplate, no need to declare exception in function signatures through exception. Conclusion, exception handling in Python is similar and more flexible than Java. In Python is simpler and more flexible than Java. Okay.
So let's start by writing a small program to get the user's age from the terminal. So we call the input function input at. In this tutorial, I'm going to teach you guys how to handle errors in your Python programs. So let's start by writing a small program to get the user's age from the terminal. So we call the input function input, add a label here like age. This returns a string, so we need to pass it to the int function and then store the result in a variable called age. Now let's print age to make sure we have implemented everything properly. Run our program. We type 20. 20 is printed here, beautiful. Now look at the exit code of this program. Exit code 0 means our program terminated successfully. There were no errors. But what if we run this program one more time, and instead of entering a numerical value, we enter something like ASD. We get a value error with this message, invalid literal for int with base 10. Basically what this message is telling us is that this string ASD does not contain a valid whole number that can be converted to an integer. Now look at the exit code of this program. Exit code 1 means our program crashed. So 0 always means success, and anything but 0 means crash. Now, as a good Python programmer, you should anticipate these situations. You don't want to let your entire program crash just because the user entered an invalid value. So instead of letting the program,
Important thing.
as a good Python programmer, you should
anticipate the situation. It's very important. As a good Python programmer, you should anticipate this situation. You should anticipate any kind of error that the user can cause. So it's very important as a good Python programmer.
In these situations, you don't want to let your entire program crash just because the user entered an invalid value. So instead of letting the program crash, you should handle this situation and print a proper error message. And that's what I'm going to show you in this tutorial. Now, if we're going any further,
you have to show the customer. You have to show to the code. You have to show to the customer how can proceed, how can he proceed, how he can proceed after an error because he didn't read because he didn't read properly. Okay, I got you.
Look at the type of the error we get here, value error. So remember this, we're going to get back to this shortly. Now, how can we handle these errors? In Python, we have a construct called try except. We use that to handle errors. Let me show you how it works. So on the top, we type try colon. Now, as you know, we're defining a code block. So I'm going to move these two lines inside of our try block. So press tab here and remove this blank line. Now, these two lines are part of our try block, right? So after try, we type except, and then we add the type of error that our program may encounter. That is value error. Okay? Then we add a colon, and in this block, we can define what should happen if our program encounters an error of type value error. In this case, we want to print a proper error message. So print invalid value. So with this try and except, we're telling Python, hey, go ahead and try running these 2 lines of code. If you encounter an error of type value error, then instead of crashing the program, print this error message on the terminal. So this is how this works. Now, more accurately in programming terms, we refer to this kind of error as an exception. So an exception is a kind of error that crashes our program. So if the user enters an invalid value, this line of code, line 2, will raise an exception, and on line 4, we'll catch it and print this error message so our program will no longer crash. Let me show you. So let's go ahead and run this. Age 20, everything works just like before, and the exit code is 0. Beautiful. Let's rerun this program and enter ASD. So we get this proper error message, invalid value, and once again, the exit code is 0. So that means our program completed successfully, it didn't crash. Now, we can also handle different kinds of errors or exceptions. For example, right after we get the age, let's define a variable, income, and set it to 20,000. And then define another variable called risk and set it to income divided by age. Let's run this program and enter 0 as the age to see what happens. So 0 is obviously a numerical value. So when we enter this value, technically we shouldn't get any exceptions. Take a look. Our program crashed with a 0 division error because we cannot divide a number by 0. Once again, look at the exit code. So we couldn't catch this kind of error or this kind of exception with this except block. This except block is only catching exceptions of type value error. And this happens when we try to convert a non-numerical value to an integer. So in a situation like this, we should handle different kinds of exceptions. We can add another except statement for an exception of type 0 division error. Now in this block, we can print
this cannot be handled with the exception error is by 0 by 0. Okay, but my question is how many exception exists in Python? In Python there are many built-in exceptions that you can catch. Many categories: all arithmetic errors, or divisor, overflow error, number too large, float, lookup errors when trying to access an invalid index or key, type errors, okay, value errors, import errors, which there are many categories, main categories for NVIDIA categories. I guess error, general system error, directory error, variable not defined, unbound local error, memory error, system exit, full list of built-in exceptions. Python has more than 6 built-in exceptions. You can use them all using example handle multiple sections. Python has more than 6 you can handle all exceptions inherited from the exception. You can handle multiple exceptions in 1, try except one try except load. Okay.
A different kind of message, like age cannot be 0. Let's run our program one more time. Now I'm going to enter 0 as the age. So we get this error message, age cannot be 0. And look at the exit code. It's 0, so our program didn't crash. So to recap, we use try except blocks to handle exceptions that are raised in our programs. As a good programmer, you should always anticipate these kind of exceptions and handle them properly.
And handle properly. Comments, okay. Ok, vamos a guardarlo. Git add punto git commit exceptions git pull por unas prácticas y git push. Listo, vamos con comentarios. Terminamos la tercera hora de este Python Full Course for Beginners. Hemos avanzado, vamos a darnos las gracias. Bueno, muchachos, nos vemos en el próximo para comentarios. Realmente ya falta poco. Vamos. La última 2 horas, básicamente, es ya creando programas con Python. Building a website with Django. Ok. Clases, nos faltan clases, constructors, inheritance, modules, package, generating random values, working, PIP, pipe, automatization with Python. Ya casi, vamos que sí se puede. Constancia y disciplina. Bueno, gracias. Nos vemos dentro de 5 minutos. Bye bye.